So we have to start theorem 10.2. If the angle subtended by the chords of a circle at the center are equal. So we have taken the two chords. This is chord AB, and CD. And O is the center of the circle. Then these two chords, what is given? These two chords are making equal angle. This is also making equal angle. That means we have given this angle. This angle is equal to this angle. These two angles are equal. We have to prove that the chords are also equal. Okay, that means we have to show that. So we have given the, we will write what is given. We have given two chords AB and CD. AB and CD of a circle C of center O and any radius R, such that they are making the same angle. So it is given that the angles are equal. So therefore we'll say that angle AOB is equal to angle COD. And we have to prove what we have to prove. We have to prove that these chords are equal. To prove that these chords are equal, that means AB is equal to CD. This we have to prove. Okay. To prove, we will consider these two triangles. So if you see this AO, I'll tell you first AO is equal to CO, correct? Because these are the radii, and this angle is equal to this angle, and this side is equal to this side because both are the radii. Side angle side. So by using side angle side, we can prove that these two triangles are congruent triangles. So in triangle AOB and triangle COD. AOB, first I have taken AOB, so AO side will be equal to CO. Why? Because these are the radii of same circle. Okay, that's why they are equal. Then angle AOB, side angle side we are using. So the angle AOB will be equal to angle COD. It is given in the theorem that angles are equal. So that is given. Then OB is equal to OD. Same reason OB, OD are the radii of the same circle. That's why they are equal. They are the radii of the same circle. That's why they are equal. So by using, therefore, by S congruency, triangle AOB is congruent to triangle COD. When they are congruent means all the sides, all the angles are equal. So therefore, AB is equal to CD. AB is equal to CD by CP, CT, hence proved. Okay, got it. So two circles are congruent if they have same radii. Means their radius are same, then they are congruent circles. Prove that the equal chords of congruent circles subtend equal angles at their center. This is the theorem, same theorem. But here they consider two different congruent circles. So we have to take two congruent circles separately. We have done the theorem in the same circle. So the theorem is valid for congruent circles. So these are two congruent circles. They have same radii. Prove that the equal chords means these are congruent circles. They have same radii. They have same center. Suppose it has center here. So it will have center here. Okay. And there prove that the equal chords. So it has one chord whose length and the length of this chord, they both are equal. It is given in the question. This is suppose AB and this is CD. These are two equal chords. Because it is given in the question, they are equal. So these are two equal chords. That means AB is equal to CD is given. And these are two congruent circles. So how we will write? We will write the given two circles. This is given us these two circles. So given two congruent circles. So they have same radius. So how we will define? They have different points for their center. So this has here this center O dash. The two congruent circles C1, C2. We can say this is C1, C2. We used to write like this. I told you the C1 is a circle whose center is O and whose radius is R. And C2 will also have, it has different point for center, but the radius is same because they are congruent circles. Two congruent circles are given. It is given that two congruent circles such that the chords are equal, means AB and AB is equal to CD, such that you can write their chords are equal. That is AB is equal to CD. Okay, got it? And we have to show that subtend equal angles. So now we have to do the construction, means angle, they are subtending equal angles, means this line is subtending an angle here, or this chord is subtending an angle here. We have to show that these two angles are equal, means this angle will be equal to this angle. Okay, these two angles will be equal. This we have to show. So we cannot show these two angles. We can give only numbers 1 and 2. Got it? So what we have to prove? We have to prove that angle, it is similar that we have done in the theorem. Angle AOB is equal to angle CO dash D. Again, SSS theorem is applied here. All the three sides of this are equal. In triangle, you'll consider the triangle AOB. In triangle AOB, and triangle CO dash B AB is equal to CD. Why? Because it is given in the question they are equal, and OA is equal to O dash C because they are the radii of the same circle, radii of same radii of congruent circles. Here same, no? Here we have two different circles. So different circles, but they are congruent. So they have same radius. Radii of congruent circles. Here we'll write the radii of congruent circles. And the third one, OB, is also equal to this with the same reason. O dash D, they are also the radii of the congruent circles. So therefore by SSS congruency, SSS congruency, triangle AOB is congruent to triangle CO dash D. When they are congruent, that means by CPCT all things are equal, angles are equal. Therefore, we can say that angle AOB will be equal to angle CO dash D by CPCT. Okay, hence proved. So here again we have to take two congruent circles and these two are congruent circles. These circles, chords of congruent circles subtend equal angles. Now chords are not equal, angles are equal. We have to show that the chords are equal. That is the converse of the previous question. We have given a chord. This is a chord. This is another chord, means chord of the second. And they are making equal angles at the center. Means this chord, suppose this is the center, is making this angle, this chord, and this chord. These two angles are equal. Suppose this is chord AB and center is O. This is chord CD and center is O dash. So this angle is equal to this angle. It is given. We have to show that the chords are equal. In the previous one, angles, we proved the angles are equal, chords were given equal. Now we have given angles are equal, we have to show chords are equal. So obviously side angle side, this OA will be equal to CO dash. Then this angle is equal to this angle and this side will be equal to this side. So side angle side, they are congruent. When once they are congruent, then by CPCT AB will be equal to CD. So we have to write the given two. Again, this is let it be C1, circle number C1 and C2. C1 has center O and radius will be same because they are congruent circles. So radius we have to take same. If they are different circle, I will take R1, R2 or R dash, different radii we have to show. So we have given the two chords, two chords. Two chords AB and CD of congruent circles C1 with center O and radius R, and C2 with center O dash and radius R respectively. And we have to prove what we have to prove? To prove that the angles are equal, chords are equal, sorry. So we have to prove chords are equal, chords are equal. So that means AB is equal to CD. We have to prove AB is equal to CD. So proof, when these two triangles in triangle AOB and triangle CO dash T, AO is equal to CO dash. Why? Because these are the radii of congruent circles. Here you will write congruent circles. First we are taking two congruent circles. Radii of two congruent circles. Okay. Then angle also given. It is also given. We should write respectively such that angle AOB is equal to angle CO dash T. Also add this one in given condition. So angle AOB is equal to angle CO dash T. Reason? Because this given us that the angles are equal. Then the third side OB is equal to O dash D. This also equal because of the same radii of congruent. These two are the radii of congruent circles. So therefore, by side angle side congruency, we can say that triangle AOB is congruent to triangle CO dash T. Therefore, by CPCT, AB is equal to CD by CPCT. So we have finished this exercise. 1 minute time.